Hello guys, so in today's video, we are going to discuss a couple of things. First, we will see how to define variables in Java, and we will also dive a little bit into the Java memory model, and then we will discuss the difference between statically and dynamically typed languages. So let's dive straight into this. So what are variables? Variables are a way of storing data in memory temporarily. In Java, we have 8 primitive types, and each of these primitive types have specific size associated with it, shown in the chart here. Almost every languages have basic primitive types, and these primitive types help define all other data types. For example, string class, which is a data type provided by java.lang package, which is part of Java. Okay, so let's see how to define a variable in Java. So we're going to use an int. So int is a data type which stores integer values from 0 to 2 to the 31 power. So int, and we can name this variable anything we want. So let's say a, okay, and this will be assigned a value of 1. All right, so we are assigning a value to the variable a, which is a type of int. Okay, so this is how we define a variable in Java. Let's do another one. Let's say if you want to define a decimal value, so we can use a double. So in double, we can, let's say, call it b, and we can say this stores decimal values. All right. What if we want to store characters? All right, so for that, we have char. So char stores a single character. Okay, so let's say S. What if we want to store string, like a paragraph or a sentence? For that, we use a string class. Now, string class is a data type which is part of java.lang package. All right, so over here, we could say maybe, subscribe to Mr. Programmer. So what if we want to calculate the results of A and B and like add them up? How would we do that? So we can define, let's say, a new variable, let's say result, and we can add the values of A and B. So we're getting the value of A, variable A, which is 1, and the value of variable B, which is 2.2, adding them up and storing them in a new variable called res. And let's print that out. res sys. So there you go, 3.2. We can maybe change this up to, let's say, 55.5 and let's say 10. So we should get 65.5. All right. We can do the same thing to this variable string. So let's say we have another string called like, let's say like this video. All right, like this video, and we can join these strings together. Let's say we call it result. You can say S. To join the string together, we use concat. So concat with like. All right, so maybe we can add, let's say, and also plus like. Okay. Let's print that out as well. Replace it with result. All right, so there you go. Subscribe to Mr. Programmer and also like this video. So this is how you store results in a new variable result, and over here, res. All right, so let's go over what a local variable is. So local variable is something that is local to a method or if statement or conditional statements. Okay, so for example, this res is local to this main method. C, B, and A, they're all local to this main method. We can only access these variables within this method called main. All right, we can do something, let's say, similar to if block. Let's say we have an if block where we're checking, let's say, if A is even. Okay, so if A is even, maybe you want to do something with those numbers. Okay, let's say we have this new variable called, let's say we want to add up A plus B. Okay, we cannot access this variable outside of this if block. This is only local to this if statement. So for example, I cannot print this new res out. If I do this, it's going to say this method is not set. All right, it's not within this scope. So we can, but we have access in here. So we can run this. There you go. Result is 3.2. Same thing, let's say we have a for loop. Okay, so for, and let's say I equals 0. Now I'm going to have a separate video on if statements and how loops work, so you guys can check that out. But let's do something like this. If I plus plus, all right. So this I is local to this for loop. That's it. And let's say maybe we have something called string s2, okay, is equal to hello. All right. So s2 is local to this for loop. Let's create a function. All right. Again, I'm going to have a separate video on functions that you guys can check out. Let's create a function that returns maybe a double and adds up two numbers. Okay. Let's say adds up, takes this. And let's say we have sum is equal to a plus b, and we return the sum. Now sum is local to this method or function add. We cannot access this result or this variable outside of this method. So maybe we can replace this with, let's say, add a and b, okay? And we're storing that result in a new variable called res. So let's run this. There you go, 3.2. Let's change up this value to maybe, 0.54, and this to something else. So we got some result there. All right. So this is what local variables are. So let's quickly go over what an instance variable is. That's another type of variable that's defined within a class. Now, I'm going to have a separate video detailing object-oriented programming, and we'll go over that more in detail. But over here, let's do an example of an instant variable. So let's say we have instant variable int x and int y. Maybe these can be coordinates, okay? And let's create an empty constructor. So in our IDE, we have this way that maybe takes in these two variables, okay? And maybe we have, let's say, the getters and setters for it as well. Okay. All right. So what an instance variable is that this variable is only part of this variable object. So when we instantiate a variable class, we are going to get access to these variables, x and y. That's an instance of that object. Okay. So let's do that here. Maybe let me comment this stuff out. And let's do this. So for example, if I do variable v is equal to new variable, and that takes in, let's say, coordinates 1 and 2. Okay, x and y. And let's say I want to get access to that variable x. So we can do v dot x, okay? V dot x. And let's copy this. V dot y. All right. So x and y are instance variable of this object v. All right. So let's print this out. We should get 1 and 2. We can create a new object. Let's copy this. Let's create a new object. We'll call this v1, and that takes in maybe, let's say, 24, and this takes in some other large number, and we can print this out. So v1 and v1. So let's run this. There you go. So these are instance variable of this class, of this object v1, and these are instance variable of v. Now, last thing I want to go over is global variables. Now, Java doesn't really have a concept of what global variables. However, we could do something like using a static keyword. We can define a variable. Let's say that is public, static, and let's say it's a string and it's hello. Okay. And it is Mr. Programmer. So all the instances of this class will have access to this variable hello. So we don't need to instantiate a new object for variables. And what I mean by that is, if I print this out, I can directly do variables dot hello. So I have access to hello this way. All right. Let's run this. Mr. Programmer. Okay. So over here, I did not need to create a new instance of this class variable. I can directly access this variable hello via the variables class. All right, so the next topic I want to go over is a Java memory model and how data is stored in memory. So almost all data in memory is stored in binary format. So for example, we have this variable n that is a decimal 10. This is going to be stored in a binary format. So we can even see how that will be stored in memory. So we can print it out. Print ln integer to binary string, and we can pass it a. So let's see how 10 would be stored in this format, in a binary format. Even character and strings are also stored in binary format. And the way that works is it uses ASCII encoding. So ASCII is basically a character encoding standard that's been set for electronic communication. These codes basically represent text that computers and electronic devices understand. So for example, if I have a character, let's say, let's B is equal to, let's say A. All right, let's have a character A. I can get the ASCII code for that. Let me print that out. B. So the ASCII code for for A is 97. And this is described in this ASCII chart shown here. Okay, so A has an ASCII code of 97. And in binary, that's a format. Okay, so the next topic I want to dive into is a Java memory model. So let's take a look at how these variables, these methods, and these objects are stored inside of memory. Okay, so Java uses something called JVM, which is a Java virtual machine. And this resides inside our memory or RAM. It allows us to run Java application from anywhere, which is where the motto came in. Write code once and run anywhere. Another nice thing about JVM is that it manages the memory for us automatically, unlike languages like C or C++, where we have to manage the memory ourselves by using something called calloc and malloc for allocating memory and manually cleaning it ourselves. So there's a process inside JVM called garbage collection. And this garbage collection basically automatically cleans up the memory for us. We don't have to do it ourselves. So the two big parts of JVM are stack and heap. Stack takes up small amount of memory compared to heap. Whenever we call a method, we store all of its local primitive values and references to other objects inside the stack. Now, stack is a last in, first out data structure. What that means is we have this stack. It looks like this. And anything we store would be, let's say, last in. Let's say we called a method, let's say, add, okay? And then right after that, we called a method called, let's say, subtract, okay? So subtract would be the first one out, and then add would be next, all right? And so as soon as we call this method, the block inside this stack would become available. So when we call add, this will pop out, right? And this block will become available. Now, you might see or encounter an error called stack overflow. And this basically happens when we run out of stack memory. So recursion is one of the ways that uses up a lot of stack memory, because with recursion, we're calling methods multiple times. So we have to be careful on that. Heap, on the other hand, is where we store and allocate memory to objects and the Java runtime classes. Whenever we create a new object, it always creates it in the heap space. Also, this is where the garbage collection runs to free up the memory used by all these objects that don't have any references left over. And if the heap memory ever becomes full, we get out of memory error. And so when we're designing large application, it is important to allocate large memory to heap. This is done by configuring one of the flags inside of JVM. All right, so let's do a small example. All right, so as soon as we run the program, the Java runtime first loads all the Java runtime classes onto the heap space. So this is our heap. In the next line, when we call the main method, this gets loaded onto a stack frame. So this is our stack with the main method. Now, inside the main method, we are creating two local primitive variables, A and B. So these primitive values get loaded onto the stack as well. So A is equal to 1 and b is equal to 2.2. So any local primitive values always get loaded onto the stack frame for that method. So on the next line, we are calling a add method. So this add method gets loaded onto a stack as well. So it gets loaded on top of the stack with its parameter values a and b as well. Now inside the add method, we are also creating a new local variable, primitive variable sum, with its values of a and b added. So sum is equal to a plus b, and this gets loaded onto the stack frame or on the add method. So on the next line, we are returning sum. So we're returning back to the caller. We're returning back here. And what happens is add method gets popped out of the stack and main gets pushed on top of the stack. So this block becomes available. So this is free now. So this becomes available. Okay, so we're storing the result of the add method inside of res. So let's just create a new stack just to make it easy to read. So we have our new stack that only has main method left in there with its variables a is equal to 1, b is equal to 2.2, and res, which is the result of the add method. So next, we are creating a new object, var. So object is var of class variable. And we store this var object onto the heap. So we have our variable class that gets instantiated. And we also have the instance variable x and y. X and y. And we store the reference onto the stack. So the reference is var. Okay. So this var is pointing to this class. All right. With its instance variable x and y. And finally, when we exit out of the main method, this main method gets popped out of the stack, so this stack becomes available again, and the garbage collection destroys this object, okay? So this gets freed up by the garbage collection. So this is a brief overview of a Java memory model, and the next and final topic I want to dive into is the difference between statically and dynamically typed languages. So what is statically typed? So statically typed is where we are enforcing the type of a variable. So here, for example, we are enforcing that, hey, A is of type int. So over here, we can only store whole numbers. B is of type decimal, double. So we can store decimal values. In this case, so I cannot assign, let's say, A is equal to 2.2. I can't do this. I'm going to get an error. So you can see here, required type int. Okay, if I try to run this, I'm going to get a compile time error. So we can see it here, incompatible type. So Java is a strongly typed language. We have to enforce a type, which is check that compile time. The advantage of this is that it makes it less error prone, and it also tends to perform faster than dynamically typed languages. Now, there is another JVM language called Groovy, which is dynamically typed and is very similar to Java, and where we can also use Java classes. Python is another dynamically typed language, and I will have a separate video for Python where I will go into details on how variables in Python work and the pros and cons of being dynamically typed language. Hopefully you guys got a better understanding of variables in Java, and we went over a couple of topics today, like variable declarations, the Java memory model, and we touched the topic of being a statically typed language. I will have another video very similar to this for Python, so check that out if you guys are interested in learning more about Python, and please do remember to subscribe. Thank you.